Hello friends, welcome to the channel Can You Solve It? Today we are going to solve ultimate number divisibility problem. The question is, a 9-digit number is formed by using the digits from 1 to 9 without repetition in such a way that the number formed by taking its first digit is divisible by 1, first 2 digits is divisible by 2, first 3 digits is divisible by 3 and so on. Can you find the 9-digit number? Before proceeding, let me explain the problem first. There is a 9-digit number, let's just say it is A, B, C, D, E, F, G, H, I. The number is found by using the digits from 1 to 9. We need to find the individual digits in this unknown 9-digit number. It is given in the problem that the number formed by taking its first digit is divisible by 1 and the number formed by taking its first 2 digits A, B is divisible by 2. Similarly, by taking its first 3 digits, then the number is divisible by 3 and so on. A, B, C, D, E, F, G, H, I is divisible by 9. Now, one way to solve this problem is by using trial and error method. You list out all possible 9-digit numbers and look for the number which satisfies the conditions given in the problem. Now, A to I, they can be any of these 9 digits and there are 3,66,880 possible 9-digit number combinations, which makes it very tedious to find the answer by using trial and error method. However, this problem can be easily solved or at least can be simplified enough to solve it by using divisibility rules. Let's find what these rules are. Now we have used this phrase divisible by in our problem several times. Let's just find what is the meaning of this phrase. If a number x is divisible by y, it means y completely divides x without leaving any remainder. For example, 35 is divisible by 5, but 56 is not divisible by 5. Now, let's learn some of the divisibility rules. Divisible by 2. If the last digit of the number is either 0 or divisible by 2, then the entire number is divisible by 2. For example, 2, 3, 4, 6 is divisible by 2 because 6 is divisible by 2. 4, 5, 7 is not divisible by 2 because 7 is not divisible by 2. Divisible by 4 rule. If the number formed by last 2 digits of the number is divisible by 4, then the entire number is divisible by 4. For example, 5436 is divisible by 4 because 36 is divisible by 4. 618 is not divisible by 4 because 18 is not divisible by 4. Divisible by 8. If the number formed by last 3 digits of a number is divisible by 8, then the entire number is divisible by 8. Example, 92712 is divisible by 8 because 712 is divisible by 8. 8926 is not divisible by 8 because 926 is not divisible by 8. Divisible by 3. If the sum of digits of a number is divisible by 3, then the entire number is divisible by 3. Example, 2346 is divisible by 3 because the sum of its digits is 15, which is divisible by 3. 457 is not divisible by 3 because the sum of its digit is 16, which is not divisible by 3. Divisible by 9. If sum of digits of a number is divisible by 9, then the entire number is divisible by 9. For example, 459 is divisible by 9 because the sum of its digits, which is 18, is divisible by 9. 2346 is not divisible by 9 because the sum of its digits is 15, which is not divisible by 9. Divisible by 6. If a number is divisible by both 2 and 3 separately, then the number is divisible by 6. For example, 2346 is divisible by 2 because the last digit 6 is divisible by 2, and 2346 is also divisible by 3 because the sum of its digit, which is 15, is divisible by 3. 454 is not divisible by 6 because although it is divisible by 2, it is not divisible by 3 because the sum of its digits is 13, which is not divisible by 3. Hence the number is not divisible by 6. Divisible by 5. If the last digit of a number is either 0 or 5, then the number is divisible by 5. Example, 2340 is divisible by 5. 458 is not divisible by 5. Divisible by 7. This rule is little bit tricky. If the number formed by taking the difference between twice its last digit from the rest of its digits is divisible by 7, then the entire number is divisible by 7. For example, 231 is divisible by 7 because twice its last digit, which is 1, from rest of its digits, which is 23, then we get 21. 21 is divisible by 7, so the entire number, that is 231, is divisible by 7. Similarly, 459 is not divisible by 7 because twice the last digit, which is 9, is 18. If we subtract 18 from the rest of its digits, which is 45, we get 27, and 27 is not divisible by 7. Equipped with these rules, you can try to solve this problem on your own and then you can proceed for the answer. Let's try to solve this problem. We know that the unknowns A to I can be any one of the digits from 1 to 9. by using divisibility rules, we try to simplify or at least eliminate some of the possibilities. Now it is given in the problem that if you take the first 5 digits, the number should be divisible by 5. That means, as per divisibility rule 5, E should be either 0 or 5. But 0 is not possible because 5 must be from 1 to 9. So E must be 5. Since E is 5, the remaining digits cannot be 5. Let's simplify this further. We know that if we take the first 2 digits A, B, it is divisible by 2, which means B is divisible by 2. For B to be divisible by 2, the options available for B are 2, 4, 6, 8. Similarly, if you take the first 4 digits, the number should be divisible by 4. Since the number is divisible by 4, the number should also be divisible by 2, which means D should be divisible by 2. So D should be among 2, 4, 6, 8. Similarly, A, B, C, D, E, F, the first 6 digits should be divisible by 6. That means it should also be divisible by 2. That means F also should be among 2, 4, 6, 8. Similarly, the first 8 digits should be divisible by 8. Hence, H also should be from 2, 4, 6, 8. Now we have 4 unknowns and 4 possible numbers. That means these 4 unknowns must be 2, 4, 6, 8. Not necessarily in that order. This also means that the other unknowns A, C, G, I, they should be among 1, 3, 7, 9. Not necessarily in that order. Because 2, 4, 6, 8 is taken and E is 5. By doing this simple calculation, we have reduced the number of possibilities from 3,66,880 to just 576. Let's try to simplify this further. We know that the number formed by taking the first 4 digits is divisible by 4. A, B, C, D is divisible by 4. That means as per divisibility rule 4, the last 2 digits of the number should be divisible by 4. That is C, D is divisible by 4. Similarly, the first 8 digits should be divisible by 8, which means the number should also be divisible by 4, which means GH is divisible by 4. Now CD and GH both are divisible by 4. The possible combinations for CD and GH are C and G can be any of the number 1379 and D and H can be any of the number among 2468. So there are 16 possible combinations for CD and GH. But we know that CD and GH are divisible by 4. So we can eliminate all those numbers which are not divisible by 4. So these numbers cannot be CD or GH. So the only possible options for D and H are 2 and 6. Which means if D is 2, H is 6. If D is 6, then H must be 2. And also, previously we determined BDFH must be among 2, 4, 6, 8. Now we know that DH must be 2 and 6. That means B and F should be among 4, 8. Let's substitute these in our table. Now let's see if we can simplify it further. We know that the first 6 digits should be divisible by 6. That means it should also be divisible by 3. As per divisibility rule 3, the sum of its digits, that is the sum of A, B, C, D, E, F should be divisible by 3. We also know that the number found by first 3 digits A, B, C is divisible by 3. That means the sum of the digits D, E, F should also be divisible by 3. So that the entire number is divisible by 3. Now let's see what are the available options for D, E, F. D we have 2, 6, E is 5, F we have options 4 and 8. Let's put that in the table. See, D we have 2, 6, F is 4 and 8. So if D is 2, F can be either 4 or 8. D is 6, F can be either 4 or 8. So these are the possible sums, out of which 11 and 19 are not divisible, which we can eliminate. So this means when D is 2, F must be 8. Now when D is 6, F must be 4. Previously we don't know when D is 2, what should F be? We know H is 6, but we don't know what F is. Now we know. We can substitute these values in the table. When D is 2, F must be 8. Then the only number left is 4 for B. Similarly, when D is 6, F is 4 and the only number left 8 should be B. Now after doing this, we successfully reduced the number of combinations from 576 to just 48. Now to simplify it further, let's assume that one of these two combinations 4286 or 8642 is true and see if we can find the 9-digit number. Let's take 4286 first. Now we know that the first 8 digits should be divisible by 8. That means the last 3 digits of the number should be divisible by 8 as per divisibility rule 8. Now FGH, we know F is 8, H is 6. Now the possible combinations for FGH are 4 possible combinations because G can be any of 1379. Out of these, if we eliminate those combinations which are not divisible by 8, then it leaves us with 816, 896. It means G can only be 1 or 9. Now, the entire 9-digit number should be divisible by 9. That means it should also be divisible by 3. We know that A, B, C, D, E, F, which is the first 6 digits, is divisible by 6. That means it is also divisible by 3. It implies the last 3 digits G, H, I should be divisible by 3. That means the sum of each digits should be divisible by 3. Now let's see the possible combinations for G, H, I. Now when G is 1, I cannot be 1. Now when G is 9, I cannot be 9, but it can be any of these 3. So the sum of all these combinations are given here. We can eliminate those combinations which are not divisible by 3. There is only one combination which is divisible by 3, which is G is 9 and I is 3. So we found out that when G is 9, I must be 3 and G cannot be 1. It is not possible. So G is 9 and I is 3. That means the remaining numbers 1 and 7 must be A or C. So far we have used up all divisibility rules except for 7. Now by using this rule, we will try to find the answer. Now these combinations only give 2 possible 9-digit numbers. These are when A is 1, C is 7. When A is 7, C is 1. Remaining numbers are already assigned. So from among these 2 numbers, we will look for the answer by using the divisibility rule 7. So let's take the first 7 digits of these 2 numbers and apply divisibility rule 7 to find out if the number is divisible by 7. So as per the rule, if we subtract twice the last digit from the rest of its digits, the number should be divisible by 7, so that the entire number is divisible by 7. We subtract 18 from the rest of the digits, we get this. We'll repeat the process until we get sufficiently smaller number so that we can easily divide it by 7. Now C2 is not divisible by 7. Similarly 74 is not divisible by 7. It means none of these combinations are divisible by 7. That means our original assumption that B, D, F, H should be 4, 2, 8, 6 is wrong. That means the other combination, which is 8642, must be true. Now let's take B, D, F, H as 8642 and try to find the 9-digit number. As we found out previously, now the first 8 digits should be divisible by 8. That means FGH should be divisible by 8 as per divisibility rule 8. Now let's look at the possibilities for FGH. F is 4, H is 2. These 2 are fixed. Now G can be any of 1379. We eliminate those possibilities which are not divisible by 8. This leaves G with only 2 possible numbers, 3 or 7. So G cannot be 1 or 9. Now the first 9 digits of the number should be divisible by 9. This means the number should also be divisible by 3. Again, the first 6 digits are divisible by 6. That means the number is divisible by 3, which implies GHI should be divisible by 3. That means the sum of the numbers GHI should be divisible by 3 as per divisibility rule 3. Now let's look at the possibilities for GHI. When G is 3, I cannot be 3. I can be 1 among 179. Similarly, when G is 7, I can be 139. Now let's eliminate all those combinations whose sum is not divisible by 3. There are only 2 possible combinations whose sum is not divisible. Now out of the remaining, what we can say is when G is 3, I can be either 1 or 7. Similarly, when G is 7, I can be either 3 or 9. Similarly, if we take ABC, it should be divisible by 3. That means the sum of the 3 digits ABC should be divisible by 3. Now let's look at the possible combinations for ABC. Now as you can see that all these possible sums for ABC are divisible by 3. This means all these combinations for GIAC are possible. Now we have already used all divisibility rules except for 7. Now we use the divisibility rule 7 to find the answer for the problem. Let's take all the 7-digit numbers and apply divisibility rule 7, which is take twice the last digit and subtract the number from the remaining digits. and see if that number is divisible by 7. This is the number we got. Now we repeat the process until we get a sufficiently smaller number so that we can easily find out if it is divisible by 7 or not. Among all these numbers, only one number, that is 28, is divisible by 7. That means the corresponding combination for 7-digit number 3816547 is divisible by 7. All other 7-digit numbers are not divisible by 7. Only one number is divisible by 7, and the corresponding 9-digit number is 381654729. This is our answer. So we finally find out the 9-digit number, which is found by using the digits 1 to 9 and satisfying the conditions given in the problem. Now from this table you can see that if you take the first digit, it is divisible by 1, first 2 digits are divisible by 2, first 3 digits are divisible by 3, and so on. It is easy to remember this number, although it appears to be very random. If you look at the number pad of keyboards, the numbers are usually represented like this. The 9-digit number that we found out is 381654729. It is easy to remember this number like this. That's it. Thank you. Hope you enjoyed this. See you on the next one. And don't forget to subscribe for getting updates on new interesting puzzles.